Hello, welcome to part 2, and this is the result we will end up after this video. I'm not gonna render this out in this video because it took me a while to create this. I think it takes longer than 1 hour, so let's get started. So this is the file where we left off last time. I'm gonna make a few changes since I switched to Houdini 13. And Houdini 13 has some new fancy shelf tools, which and the one I'm gonna use is the draw curve one. So I used to use the paint sop and paint some red here and create a curve out of that, but now I can use this one instead, the draw curve tool. So we're gonna change that first. I'm gonna delete the lights first, which I already did. And we're gonna change this part. So let's see. First disconnect this. And let's see. Yeah, we're gonna delete everything above this. And connect the first input to the laptop. Then we need to delete these and use the draw curve tool. So with this one selected, enter the draw curve tool, and we're gonna paint something like this for fun. Let me organize this a bit. So this is the draw curve tool. Don't know what this is. Oh, this one got moved around somehow. Oh yeah, for the painting part. Yeah, I'm gonna leave it in here. So we have this curve. Plug it in the crack tool, and let's see if things are broken. Yeah, it still works. So that's nice. Let me see if I need anything. No, this will work. So to make the fractures in rigid bodies and particles, I'm gonna separate this crack. So let's see when it's finished cracking. Needs to calculate. Yeah, over here. Then we did the fracture part. We have this separate. We converted it and deleted it. And I'm gonna use this one. So I need to write this out as a file. The complete crack. So I'm gonna use a ROP output driver. And I'm gonna place it in hip/geo. You can write it anywhere you like. I'm gonna write it here. I'm gonna call this crack and render this out. So now I should have a BGO file. So let's load it in to a new geometry. First I'm going to select this one. So we will have the final result of the wall. I think this is really slow for playback. Let me see. Yeah, it's quite slow. So I'm going to cancel this out, and I'm going to preview another part, which is, no, I'm going to lower it up. Yeah, this one should be faster. But instead I'm gonna increase this value, maybe 0.1, so we have a faster playback. and let me see if it's fast enough. Yeah, it's not too bad. Let's do this. This will suffice for now. Okay, this is the wall. I'm gonna create a new geometry. I'm gonna call this crack. No. Yeah, crack. Whatever. So I'm gonna load in the crack, which is this file we just wrote out, and I'm gonna hide other objects. So I'm gonna work on this part now. So first I'm gonna create an ISO offset, create a volume out of this one. So 100 should be enough. You should see some fog volume here. If you change the background to dark, you see it better. Okay, you can change the display by pressing this button, or press D for display. So let's scatter this piece. Let's try 100 parts. The reason I'm converting it to a volume is because I need to scatter points on the inside of this file. If I use the scatter on top of this one, only points will get scattered at the surface of the geometry, and this way it's getting on the inside of the geometry. Use a Voronoi fracture node. Connect the points to this part. If you press middle click, you can see what the inputs is asking. So let's see. Yeah, cooking takes a while because the geometry is quite heavy. We need to optimize that first, because this is not the fastest way to do so. So let's press the geometry and use a poly reduce, and let's preview it. And I'm gonna lower it by I'm gonna keep 2% of it, and I'm gonna stiffen the edges and the borders a bit more. Well, it didn't help, so doesn't matter. This is fine. If I'm correct, this should be a lot faster. So if I change this to 200 parts, yeah, faster update. To check if they're really fractured, I'm gonna use exploded view node. You can see they're all individual parts, but I'm gonna use 50 for now. So what I'm gonna do is I'm gonna simulate the rigid bodies first, and I'm gonna use it. I'm not gonna animate anything. Well, I mean, I'm gonna simulate every piece separately, like this. If you use this button, use cell point groups, it will separate the groups. But as you can see, when I increase this number, for example, I use $F for a frame number, press play, this is not like organized, if you know what I mean. So we're going to change that first. One way to do that is using the sort node, and we're going to sort the points by X. If you look at this axis, the red one is X. Let's look at the point number. Now it goes from 0 to 49. If you reverse it, it will start here. And if you now press play, you will see this, which is what we want. But don't like using X, and I want to use an expression for that. So let's look this part. If you take a look at the point number. 15 is the first one. So if you use the sort node and put the proximity to point, and you're gonna use point the point expression. Let's get the scatter node, point 15, parameter p for position, and the first input should get us this. So let's see. And this works, but it's still not procedural, so we're gonna change that also. And the one way to do that is go back to the wall, and let's see this part. I'm gonna create a null, and I'm gonna call this curve, and I'm gonna import it in here. So I'm gonna use object merge for that into this object. What that means is it's gonna use the transform values from this one. So it's gonna use the world space positions, and gonna use it. I'm gonna take these transform in account instead of the other one. Doesn't really matter because they're all 0. So at the wall we have a curve. This one, and this is actually the real first point. So we're gonna delete that one. Well, instead of deleting it, we're gonna keep it 0 and then invert the deletion, delete it. So we have this one, and we're gonna use the sort on that one instead. So I'm gonna create a null, first point, heat up, and create a sort node, and we're gonna use proximity to point again, but now we're gonna use the point expression on the first point. So 0, get the b, and again 0 for the x. Change this one to 1 for the y, this one to 2 for the z. Oh, you see this one got messed up. So now we have this as a this point as a reference for the first point. And now if I press play, we have this. So it should follow the curve exactly. Well, not exactly, but close enough. So first, well, let's actually create a simulation out of this one. So we're going to use fractured rigid body. Let's create a packed object out of this one. And we're going back to the crack, and now we should have a few nodes more. Somehow my cursor is not updating, so got a bit confused over here. So let's take a look at the simulation in the AutoDoc Network. Yeah, we have one piece. So create a ground plane. If you press play, it will actually fall, which is good, but we need to update this every frame. And to do so, we're going to use this. Let's move this to the side, and Control Shift click to delete the expression, and press $F. Now we have this, which is what we want, but it doesn't look that yeah, that great actually. So let's change some values. So we're going back to this file, and what we want is to push them outside a bit. Well, there's one way to do that, and that's VOPs up. And we're gonna add some velocity to these points. Press this button, which is the point trail button, which actually means velocity. And let's create a turbulent noise. Or actually make a constant node. Or instead of constant, the parameter. And let's make it vector 3. And because this is a parameter, it's getting promoted over here, so you can change values here, which is really nice. I'm gonna use this as direction. And let's put it in the V for velocity, and let's look. So press 1. Now the vectors are pointing backwards. Let's see if this works. So I'm gonna use 5, and it should not work if I press play. Nope, they're still falling down, and that is because if you look at the details view, you see we have velocity attributes here, but when we click this one, we don't have velocity. So how do we get that? Get these parameters back? One way is to click on attributes on the Voronoi fracture node, and we're gonna copy the cell point attributes, and we're gonna copy V. So now we have velocity values, but it should not work straight away. There's one part you have to do in order for it to work, and that is to go to the AutoDoc Network and inherit velocity from point velocity. If you press play, it should all be pushed forward, which is quite strange because the points were pointing backwards, but I think that's a bug. It happened to me before. Anyways, it works, so we're gonna change a bit, change some values for it to make it look a bit better. I'm gonna point it upwards and a bit forward, and I'm gonna add a noise to this one. So I can use the add node in the VOPs up and plug the position from the turbulent noise to the global position, make it 3D, and make it the sparse convolution noise because that's because I like it. You can also choose anything else, but I'm gonna use this one, and I'm gonna leave everything at default. If you look at the points now, you should see they're all pointing different directions. So I'm gonna pin this viewport. I'm gonna dive in here, and I'm gonna increase the frequency, or amplitude actually, it's better. So we have more randomized, we have more randomized velocity points. So let's press play. Well, maybe too much amplitude, so let's lower down to 2. And maybe add more in the height, just to tweak some settings. Not gonna pay too much attention to this one, and I'm going to use something in X also. So they're moving away from the crack, and from the wall, but it's just an example. So this is actually part 1 of the cracking. So now we're gonna use a particle simulation out of this one. and one way to do that is use this node as a basis. So I'm gonna use the ISO offset again, create it at 50 maybe. I'm gonna scatter points in here, something like 100 should suffice, and yeah, it should be enough. Create a new null, create it particle source, capital E. Okay, let's add a particle simulation to this one, and let's see, in the AutoDoc Network, let's move things down, create a pop object, and pop solver, and pop source. Like this, the pop solver to the merge, pop object should go in first input, and the pop source should go in the last one. Yes. You need a pop, well, I'm not really gonna explain this part too much, but how it works is you need a pop object first, which is your DOP geometry. You don't have to put anything in here unless it has some yeah, what should you say, unless you have some transformations on the geometry in here, but we have everything on 0 at the default, so we don't need that. And you need a pop source to source particles from, so we're going to use that. We're going to choose our particle source, and emission type should be points. So if we take a look at the simulation, there should be particles in here, and they're bouncing a bit weird, so I'm gonna change the physical attributes and put less bounce and a bit more friction. Let's see. Yeah, we have particles now, but we want more particles, and we want them to follow these a bit. And one way to do that is again to add some velocity points to that. But instead of adding new ones, I'm gonna transfer them instead. So I'm gonna use attribute transfer, and we're gonna transfer from VOPs up. So let me see. The velocity from points to points, and we're gonna import the DOP attributes back. So DOP input, and if I'm correct, let me see, DOP network. If I'm correct, it's called DOP pop object 1. Let's press play. Fetch unpacked geometry. This is actually the correct position. Let me, yes, it's the correct position. So now it's following the cracks, which I don't like all too much. Well, it's a bit better than first, but we're gonna use this. So we're gonna use half of the velocity, 0.5, and we're gonna add initial velocity to it, add to inherited velocity, and this should be okay. So let's see. So now we have this. just mix up all the little pieces. Maybe add some more 0.75 and add it here. Yeah, it should be enough. I'm gonna spend too much time on this part. You can tweak the settings. Zoom out a bit and let's see how it goes for the whole simulation. Yeah, it works for the whole simulation. Okay, let's go back. And let's see. We've fetched the unpacked geometry. So now we want to instance some more beautiful geometry on these points. And another way to also create random geometry for this is to use this as a source. Let's see. Oh yeah, first frame. And we're gonna use this exact node. Well, maybe we also need this one because we need packed geometry, which is new in Houdini 13, and it's awesome. And what packed geometry basically does is takes, if you look at attributes, you see it has 106 polygons and 106 primitives. And packed geometry actually packs them to one primitive. So if you look at this is less memory expensive. And we're gonna use these inputs and stamp them on these particles. Let's go to this frame. Yes. Okay. Well, first thing you can do is use a copy node and copy these parts to here. Let's see. I got it the wrong way around. Okay, so this looks a bit weird. So we're gonna change that. First, make these smaller. I'm gonna use a point node for that. And in the particle tab, I'm gonna add some scale. And I'm gonna make it 0.2 maybe, 0.1. Yeah, well, they're all the same. And what we want to do is, for each point, stamp a different crack. So we're not going to use $f, but we're going to use a stamp function in here, in the copy node. Press this button or else stamp will not work. And we're going to pack the geometry before copying. Oh wait, it is already packed, so we don't need that. So I'm going to call this random piece. And as an input I'm going to use, I'm not going to use $pt because it's a simulation and the point numbers keep changing. So I'm going to use rand. I'm going to use some random value, so 1, 2, 3 for example. It should give me a little random seed. Actually I don't need it, I can also put in 1 or 0, but I'm not going to do that. I'm going to use this. So I have this value. A rand function basically gives a value between 0 and 1. But we need to randomize all pieces in here, and for instance I know this has, let's see, 50 pieces, so I need to fit this value back to 50, from 0 to 50, actually to 49, but or else it's not gonna work. So first I'm gonna fit this value and use a fit expression, and the first input, the first part of the fit expression is the input. This is my input, this is my new minimum value, 0, and my new maximum is 49. So now if I press this button, you can see I have 46.1382, and I'm gonna change it to an integer, so I'm gonna use a ceil function. So now it's rounded to 47. If I press Alt E, you can see my whole expression. So basically I used a rand expression first. For more info on expressions, you can go to the plus and press the text port and press EX help, and there you can see all the expressions. If you don't know what rand does, you can type EX help rand, and it basically tells you what the rand function does. You can also do that for the fit 01 and the ceil. So if you don't know what I did here, you can look it up in the text port. I recommend you to do that if you don't know. And let's see. So now we have this function, but it's not stamped yet. And the way to well, instead of, I made one mistake, because I know it was 49 pieces, and a better way is to put here put an expression here, and that's counting the points. So I'm going to use a point expression, endpoints, which basically gives me the number of points of a node, and I'm going to use the scatter 01, if I'm correct, or scatter 1. Let's see if it works. Where is it? Scatter 1. Yeah. And then I was counting the points from this node. Wait, I shouldn't. Yeah, I need scatter 1. That's correct. So let's take a look at the expression now. So I added this part as my new maximum value for the rand expression, so 0 to my maximum points. And now I'm gonna stamp this part. So use stamp expression, and let's add the copy one, and let's get the random piece and just the default value of 0. This part actually doesn't do anything, but that doesn't matter. And it broke because this value, don't know what it needs. Oh, it is a, I don't know, let's see. Actually it doesn't matter. I'm gonna use backticks because it requires something else. But as you can see, it's not really randomized because I made a mistake. Is it the correct name? Random piece. Did I stamp inputs? Yes. Okay guys, somehow this part does not work with the stamping. I really don't know why, because it used to work before. I tried many different things. So I'm gonna create one test. So if this doesn't work, I don't know. So I'm gonna scatter a few points here and use the same thing. These ones should go for instancing. I've created a new sphere, by the way, and scattered in this exact same way. So now I have this. Let's add attribute. Let's call this RD, RP for random piece, rand pt, and fit 01. New minimum and maximum, so 50. I'm gonna hard code it instead of an expression, and I'm gonna see that it's not really required to do that, but I'm gonna do that anyway. Stamp input, and we're gonna stamp this with copy 3, which is copy 1. Oh yeah, of course. And change this to RP for random piece. Looks like it's doing something, but let me see. I put the fit expression in here because I thought it might work. And let's have a look. Come on. Yes, this is working. So let's decrease this to 500 points so it's calculating a bit faster. And let's use the point, give it a scale of 0.1, plug it in here. Now you should have different pieces on every point, and this part should work with the particle simulation. But I'm not gonna do it. Going to do that anymore because it doesn't work with this file somehow. But it should work. Let's continue. Okay, the next part is, let's see. What's this? Let's get the $f function back. I forgot to do something before. Now we only have the crack simulation. If you look at this, the rigid bodies, but we need the remainders of the crack. For that, I'm gonna use. Let me see. What's the best way? Well, I'm gonna use this part, but not the $f function, by the way. So I'm gonna use the opposite. So let's pack these. Well, I'm gonna pack them manually. So assemble node and create packed geometry, full geometry, and I'm gonna delete them one by one. So delete. Primitives, and let's see. I delete 0. I'm gonna delete this one. But if I do this, $f is deleted them one by one. But I want to keep them deleted. So instead, I'm gonna use a solver node, and this is the previous frame, and I'm gonna delete the first primitive every frame. So if this one's getting deleted, this one becomes the first one. So if I delete, you should get this. But if you look, you can see it's deleting. It's still leaving some geometry in here, which is not good. Let's see what's happening. Is this actually packed? It is packed, so that's good. It has an inside surface, which is also good. And it's actually, you see, it is deleting the first one. Yes. Maybe I should use a time shift, because the first frame is 1. So if I subtract 1, let's see. And I think I'm forgetting something. Why isn't it deleting just one primitive? It's not the right geometry. Maybe I should delete the group then, I suppose. Does it actually take the group into this node? This one, this is another bug. Can't be. See. Well, let's not pack them then. Okay, let's just delete the groups. So, delete let me see if this works. Still the same. Okay, there's something really weird. So they are separate. You see that it goes for this one also? No. I'm obviously forgetting something. Okay, I got it. So I actually did the same thing. This should be -1, and somehow it does work now. Don't know why it didn't work before. Anyways, it works. So if you merge those two together, let's see, this one. Let's create a null, because I don't want to overlap this with the particle source. I'm going to create this leftovers, and I'm going to object merge it into this object. Let's get the leftovers, merge them back. If you press play now, you should have this. Splendid. Next thing left, and the last thing I will do in this video, is create a smoke simulation out of this. And let's see, I am going to use this. Create a null. Piece, no, current piece. I'm going to use an ISO offset again. You can also create another volume. Let's do it actually like this. So you press VDB from polygon. Now you have this. And let's create a fog object, which is basically the same thing. And now we're going to create a source, a fluid source. And we're going to use from volume. Okay. Create a null. I call it source volume, so let's create some smoke. Let's see. Move this down a bit. Create a smoke object and a smoke solver, and fluid source. Source volume actually should go in the last one, yes. This one in the first, and let's merge it back. Let's take a look. We need to define the container first. It's really small, so I'm going to increase it to perhaps 20, and maybe 10 high. Yeah. Well, let's make this 6 and move it up a bit, not too high. It should go a bit underneath the floor. Press W for wireframe mode and something like this. Let's get our smoke object, source volume, and everything should work. It should emit smoke. Let's take a look. Here's our smoke, and let's add our velocity, and let's create some more smoke. So we're gonna put in, no, it's too much, 25 or something. See, now we have smoke coming outside our pieces, but it doesn't look too great now, and it's simulating the whole container, which is not good. So we're gonna use a resize dynamic, fluid dynamic, and put it in the resolve. So now it resizes to the smoke size. So now we can increase the smoke quality. and we can take a look now. I think something went wrong. Let's delay the frames by 1. Maybe that helps. Yes, it helps. The quality was too high for the container to keep up. So let's simulate this till every piece is being emitted, and then change some parameters. It's looking okay for now. Could be better, but I'm gonna change it later. And it still can't keep up. So let's increase the padding perhaps. Or yeah, let's increase the padding. Let's see where it stops to emit smoke. Yeah, now it's emitting from every piece. But it doesn't look that exciting. So let's make a change to that. And let's see. In the fluid source we have velocity volumes. I'm gonna add velocity. So let's push the smoke outwards. A 1. Maybe add some curl noise. And it should be all. Let's see. Looks a lot better. Maybe let's add our static wall so we can see some better results. Let's take a look at the wall. And decrease the voxel size, match it back, and let's go to frame 95 because we're now simming the cracks. Let's see. We're gonna write it out, this part. Cracked wall. Write it out and read it back in. And there it is. And create a null. And let's call this cracked wall. And let's read it back into read it as a static junction. So let's move this aside. Create a static object, and let's import our cracked wall. There it is. And let's also import another one. No, actually we don't need that. It comes later. Let's see what's next. Oh yeah, let's check our collisions. Show collision guide geometry. Press W and it doesn't look too good. So let's increase our uniform divisions. Looks better. Let's increase it more. You don't actually have to do it that precise. This is okay. Of course could be better, but this is just an example. And if I press play now, press a smooth shade, it's actually deleting one piece too much. Let's simulate this more, and let's add light, by the way. So the smoke is getting shaded. Let's see, where is it? Solving. Yeah. And let's import the smoke to a new object. Let's see, where's the crack? Here's this. And create a new geometry. This is called our smoke. And let's import from the AutoDoc smoke object 1, fetch geometry. Is it actually called smoke object 1? Yes. I think I'm gonna use another one. I can use import field instead. Let's reference the smoke object. Smoke, there it is. And let's use visualization, volume visualization, and make it a bit thicker. Maybe too thick. So now let's save the file, and I'm gonna cache it. Well, before I'm gonna do that, I'm gonna use a vertex sub, and I'm going to cusp the normals. Before I do that, I should unpack those. What's this? Leftovers. Oh yeah. Unpack. Now to smooth it. If I'm correct, I should have UVs. No. Oh wait, let's get that one back first. So let's see, -1 perhaps, and in the solver node -2, I think. Did it actually not written? Yes, it's correct. Where's the first point actually? 115, 0. Oh yeah, I think I know what happened. In the solver node, it's deleting the first one, so I'm going to use a switch for the first frame. Because we're on frame 1 and we have primitive 0 in here. So if $f is equal to 1, then it's going to be $f, otherwise it's going to be 0. Okay, pressed off. If, and let's see. Simulate. I'm going to use the flipbook. So we can watch it in real time later. Here I made a mistake in here. Let's fix that first. Should be the other way around. So this should be $f. Should be 0. And now visualize this. It's deselected. Let's re-cook the flipbook. Here now we have something like this. I can see I've offsetted the time shift by -2. Shouldn't have done that anymore. But let's look at the smoke simulation. Yeah, okay. Finishing touch, we're gonna add textures back and add some more smoke, perhaps. Well, we're at it. Let's see, time shifts. Not sure if it should be -1. I think so. Let's check it. part looks a bit weird. Let me check that one. You see? This is this node, so I'm gonna pin it. And let's see. Nothing happens. Oh yeah, of course. This one got cached, I think. So let me reset it. Yeah, it got cached, so it got some leftovers. So now that's fixed. Let's put back some UVs. Let me see. Does this one have UVs? No. So it did not get written out. In this part, in our wall, this. Oh, it pinned, so let's unpin it first. And let's see. Is this? Oh, it should be a crack. Let's delete the animation because we're not gonna animate it in here anymore. So remove the carve. And let's see. Let's use this attribute transfer. What does this one do? Oh. This one called Batman last time, but I need the UV, so I'm gonna copy this one, paste it in here. This time I'm gonna use this as an input, and I'm gonna write out this part. So let's see. Yeah, looks a bit weird, but this should work. Let's write out the crack, the BGO, and oh, let's preview the control. In the crack, let's reload it. Now we should have UVs. Yes. Let's see what happens with the poly reduce. UVs are kind of intact. So let's have a look if it actually works. Let's preview it and use the wall material from the previous tutorial. I used the quick shade last time, so let's crack that one also. What happened here? Oh, it's for the inside, and this one was outside, so I'm gonna use this node. I'm gonna copy it and paste it in here. Okay, the UVs did get fucked up. But what happens if I use the quick shade in here? The UVs are intact. So let's transfer this part. Sorry, this from this. Let's transfer back the UVs from the points. Why? Let's check this. We don't have UVs anymore. Okay. It's weird. Should get written out. Okay, let's go back to the crack. And let's... This did work, right? Oh, alright, they are vertex UVs. So perhaps... Let me see. Maybe if I increase this a bit. No, it should let me reproject them. So vertex UVs. Yes. We have them back. And now we are going to use... We should be finished. Let me see. Got fractured here. So UVs might have been messed up. So we are going to get UVs back in the end from here. One button. From the file node, so I'm gonna copy it instead. Let's use the quick shape. Yes, we have UVs back. So what I did was I used attribute transfer and projected the UVs from the vertices back. Let's take a look. You can see a small crack, but you can tweak that later. So while I'm at it, I'm going to increase the quality of the smoke. No, it's up to you. I'm gonna add some more velocity. Yeah. I'm gonna sim it. First save. And let's see if I got everything correct. This one should be static wall. So this one. And let's press the flipbook. So I deleted this one first, and it simmed, and didn't sim it, so that's because of this. See the correct simulation. It is, oh of course, I need to do this. It's simming frame 1, so we need to start at frame 0 actually. So creation frame -1 should take care of that. See. Okay, it shouldn't be -1. This was correct, but this one wasn't. So this one. This should also be -1. And finally, Okay, this one. No, this one should be -1. Okay, why is this? Okay. Maybe I should reset the simulation. Sometimes that helps. Okay, it doesn't simulate the first one. -1. Reset the simulation. Press play. So that is weird. Anyways, let's just ignore that for now. I think it's somewhere here. This one is actually deleting the correct one. Oh, of course, this should be like this. Because it's asking for a string or something. It doesn't take in expressions. So this is actually a local variable. When you subtract something from the local variable, it becomes an expression. So now let's check it. Yeah, it works. Maybe you can. We should have projected the texture also for the inside of this part. But I'll leave that up to you. So that's actually it. Because I can't wait. Oh, if you like this tutorial, please subscribe. See ya.